Okay, so this one I'm going to draw an argand diagram and shade some points. So I just put some axes here. Now you should remember to label your axes. So we've got the real and the imaginary, and then we've got to have a look and see what we've got. So we need to remember that this bit here, this is going to be a circle. Right, so we want the modulus of the complex number, so the distance from 0, to be a number. In this case, less than or equal to 3. So that is a circle. Think of the 3 as the radius. Okay. And just like your circles in Cartesian form, this tells us the centre. So that's whatever number's been subtracted, that's a translation of up plus 4 in the imaginary direction. So our centre is going to be at 4. We need to make sure we mark that because that's an important point. It's got a radius of 3, so it's not going to go below the x-axis, and you should try and make it look quite circular, really. So you should then draw in, hopefully better than me trying to do this on a pad on the screen here. Okay, a circle, and try and get yours looking quite circular. You don't put eyes on the imaginary axis. It's the imaginary axis, so we know that's 4i. It's 4, like coordinates. Okay, we'll come to the shading bit in a second because we've got this other point here. Now we want the argument between two values, so the argument being the angle. So if you are trying to find all the points that have a certain angle, normally from 0, 0 and to the origin until it's been translated, then that would be a straight line, and all the points on the line would have that angle. Now this again is a translation, so we're going to start at this point because when you've got an angle, it's only a half line. It's not a full line because if that was the origin, this part of the line here actually has a different argument because you have to go all the way around there to the top part of the line there. So this is going to be a half line. Okay, now again, it's whatever's been subtracted from Z is now where we start. So that would be subtract 3 plus 4, negative 3 plus 4i. It's like, well, that's negative 3. So it starts at negative 3 plus 4i, which happens to be on the edge of our circle. This is quite a common thing for them to do. So you do need to mark, either label that point or mark on the axis that that's at negative 3. Right, what do we want to go between? Negative pi over 2. So negative pi over 2 now. So we're going parallel from a line that is parallel to the real axis all the way round. We're going backwards because it's negative, so we're going round that way. Negative pi over 2 would be directly down. Now that's a not equal to, so that's going to be a dashed line. And then the other bit is we want to go an angle of pi over 4. So in degrees, that's 45 degrees. This is going to be a solid line because it's an equals to. Well, what's going to happen if I go at 45 degrees? Well, I'm starting on the left-hand edge of my circle, which has a radius of 3 across here. And if you're going at an angle of pi over 4, you're going up 1 for every one you go across. Well, the radius of the circle is 3, so this distance here is 3 as well, which means my half line must intersect my circle at the top there. I'm just going to tidy that up. Okay, so it looks a little bit tidier. Now we'll go to the shading. So on the circle, we want the radius to be less than or equal to 3, so that's obviously be inside the circle. And we want on our half lines, we want the circling between these two angles. So between 0 and pi over 4, which is there, and then between 0 and negative pi over 2, which is, we're going parallel to the real axis there, so that's under there. But remember, we need to be inside the circle. So we are shading all of this region. Okay. You don't have to do a heavy shade, just like diagonal lines would be fine. Hopefully yours will look a bit better than mine. Right, in order to get the full marks, it was quite common only to get 4 out of 6 marks, for example, because as soon as you make a mistake, you lose the final accuracy mark. Even my line here, there you go, didn't quite intersect my circle. It's got to intersect the top of the circle. You've got to have the centre of the circle marked, and you've got to have all the coordinates marked. Okay, now they're telling us about a complex number w, which satisfies this. Okay, so we've got this complex number w, and if you have a look, you should recognise that this looks very similar, as you can see from part A. So what this means is, but this time we've got an equals to, so w must lie on the circle. Right. And then what do they want us to find? They want us to find the maximum value of argw between these points. So we need to find where is this going to be a maximum. So if I draw a line, okay, that's a little bit thick. Okay, right, so w has to lie on the circle. So it could be anywhere on the circle, but we also want the maximum value of argw. So the maximum angle. So you can see as I move my line around the circle, here it's now off the circle. Okay, where was the last point it crossed? Was there. That's going to be the maximum, because as I move away from the positive real axis, I'm increasing the argument. So this point here is, and this is the last point the line crosses the circle, and so it's only going to touch the circle once, so it must be a tangent to the circle. So if it's a tangent to the circle, I can draw a line to the centre, and that will be at 90 degrees. We should know that from our circle theorems. Now, I've now got a right angled triangle. Because this is going up to the centre of the circle, I know that side's 4. Because this is a radius, I know that side's 3. So now I've got a triangle here. If I draw my right angled triangle back out, if I rotate it round, and this is actually the maximum argument. What I can do with my triangle is I can find that angle there. So I've got the opposite and the hypotenuse. So sine, if I call that theta, theta is going to be 3/4. We're going to want to answer in radians to do decimal places. So what am I going to have to do to get the argument? So the arg of w is going to be this bit here. So that's pi over 2 plus what you get if you do the inverse sine of 3/4. Once it's 2 decimal places, and you should get to 2 decimal places, 2.42.